So, hello everyone, good afternoon. I'd like to pitch our project, RAI6Green, robust and AI native 6G for green networks. The main challenge here is the trade-off between resiliency and energy efficiency. Because when we try to make networks robust and resilient, we have to have backup resources, extra resources that is deployed, and that's usually not good for efficiency, energy efficiency, because it consumes extra power. So here we are having these two pillars. The first is robust 6G networks, and the goal is here resiliency against network failures and disasters, reliability and availability of network services continuously, and resiliency against power cuts. We would like to capture these three items when we talk about robust 6G networks. And the second pillar of the project will be the green self-sustainable networks, which is the key goal of the project, via 3D spatial and temporal mobility prediction for extreme flexibility, via energy harvesting and flexible energy usage when no circuit power is available, and where we have AI and machine learning integrated in all network segments, benefiting fully from all energy-saving features 24 hours without fear of performance degradation. Today, you know that we can only activate these features very limited time, only nighttime mostly, so we're not really efficiently using these features. This is about my profile. I'm a professor at KTH, Royal Institute of Technology. I plan to coordinate this project together with my industrial partner, Tele2, is an operator in Sweden. Here, as I mentioned before, a little bit more detail. Green and flexible networks by design is possible. So today, networks are not really flexible and green. We are trying to manage so that we can make it flexible and green. But by design is possible by cloud and AI native network architectures, by implementing the Open RAN with integrated sensing, computing, and communication features, and enabling joint sensing, communication, and computing again. When we talk about robust and resilient networks, it will come together with the fast reconfiguration and adaptation against failures. We mean here the flexibility in terms of changing and moving network topologies also, and dynamic self-backhauling optimized together with the cloud and edge processing resources in ORAN. Here we mention AI nativeness, which will be enabling parameter-free network management. I think my time is going over, so I will skip. And main outcome and impact here we envision is two demonstrations. One is the demonstration of energy savings with machine learning and AI on live networks and digital twin, where possible. And the second is demonstration of robust, flexible networks with high resilience to disasters and network failures, and virtualized Open RAN with integration of AI for both cost and energy efficiency. Here we focus on impacts in terms of resiliency, sustainability, and cost efficiency. And the project duration is planned to be 3 years, starting in January. So I've been in touch with partners, actually coming from a previous project, AI for Green Networks project. And we are looking for additional industry partners, could be network operators, small companies, and experts in live network demonstrations and testing platforms, Open RAN, cloud and fog networking, and AI integrated networks, as well as machine learning, but especially safe machine learning. Thank you.
So please stay. We will take one question from the audience.
Yes,
Is there a question? So when you are talking about resiliency in future networks, what are the, do you see then also future businesses emerging when you have resiliencies? Can you just elaborate a bit?
Yes, I think that will enable an ecosystem where actually flexibility is possible. I mean, now we are dependent on single operators, sometimes mostly, or large operators. And when the network fails, no one can come and fix it in a very short time, like it happened in earthquake, for example, in different parts, for example, in Turkey. I was talking to Turkcell, and they had this problem of bringing up their network. In 2 days, they were suffering. They needed small companies, for example. They needed some other type of actors to come in and, be flexible and put up their networks, and also it will enable some small businesses to deploy networks in a very short time. Small networks, it doesn't have to be large, but put it up, which works for everyone, and where everyone can connect with their existing mobile phones. I mean, yeah, that's one example, but there can be other examples in terms of sustainability and green networks, actually also, mainly in terms of network management and AI.
Yeah, is there additional? There's a question.
Thank you. Would you say that your primary objective is to detect an anomaly or a failure, or is it to find the reasons behind this failure?
Detecting failure is a primary objective. Yes, one of the primary objectives, to act very fast by 2 ways. One is like with the existing networks, you need to reconfigure, you need to, but sometimes it's not possible acting only by reconfiguration of the existing networks. Then you need to bring in other resources into the infrastructure.
Okay, so then we also scheduled a consortium session for you, and it will take place on the 20th of March at 11 o'clock. So please join, but also use the time today to contact Cicek.
Okay, thank you so much for giving this opportunity to us.